In addition to integrating those basic functions, having those properties in mind, we have a couple of other antiderivative properties that we can mix in. The first is if we have the indefinite integral, or the antiderivative of some constant k times a function f of x, we can set that constant k, or that coefficient of k, aside and just integrate the function f of x dx. So if we have a constant multiple, we can set that aside. We can also, if we have two or more functions being added or subtracted, we can integrate each of those terms individually. So we could rewrite this expression as the indefinite integral of f of x dx plus or minus the indefinite integral of g of x dx, meaning we can integrate term by term. In example 6, we'll look at applying those rules. First, we could rewrite this as the indefinite integral of 7x to the negative 7th dx minus the indefinite integral of 6dx. And then we could take things one step further with that first term and bring that 7 out as just a coefficient in front, meaning we're finding the indefinite integral of x to the negative 7th dx minus the indefinite integral of 6dx. So we'll get 7 times x to the negative 6th, since we increase the exponent by 1, and divide by that exact same result, minus 6x, and then plus c at the end. Then we could just clean that up a little bit. We could write it as negative 7/6 x to the negative 6 minus 6x plus c. Checking that result, we would get negative 7/6 times negative 6 x to the negative 7th minus 6 times 1 plus 0. Negative 7/6 times negative 6 would reduce to positive 7 x to the negative 7th minus 6. We take the derivative of our result and we get back to that original starting function that we found the antiderivative of. Similarly, in example 7, we can integrate term by term and set aside any coefficients. And here we'll get negative 8 times x to the 9th divided by 9 minus 4 e to the x plus that constant c, which we could rewrite as negative 8/9 x to the 9th minus 4 e to the x plus c. And then taking the derivative of that function, we would get negative 8/9 times 9x to the 8th minus 4 e to the x plus 0, or negative 8x to the 8th minus 4 e to the x. Taking the derivative of our result should get us back to that original function. And then one last example here, which we can rewrite as negative 7 times the indefinite integral of x to the 9th dx minus 6 times the indefinite integral of x to the negative 1st dx will give us negative 7 times x to the 10th over 10 minus 6. Now keep in mind we've got something that looks like a power function, but is actually the same thing as 1 over x. So that indefinite integral will be the natural log of the absolute value of x plus c. And then if we took the derivative of that expression, we would get negative 7 over 10 times 10x to the 9th minus 6 times 1 over x plus 0, or negative 7x to the 9th minus 6 over x, which is the same thing as 6 times x to the negative first power.